Classrooms across the U.S. are transforming the way science, technology, engineering, and math, also known as STEM, are taught in classrooms throughout the nation. This course attempts to facilitate the convergence of STEM as a foundation for teaching science.
So the purpose of this class is to create science teacher leaders that understand the rhetoric and can talk to colleagues about transforming STEM education.
Today we're launching rockets. Students have designed these rockets on a CAD program called RockSim. And so that program allows them to test a number of parameters. The point is to help them learn the physics. The fun part is that they get to design and launch a rocket. In order to determine the height, we have one known angle. We have students in this physics class, everything from special ed students to AP students and everything in between. When they've taken the standardized test in the past, they tend to do much better than the general population. It seems that they understand the material better if we're not just focused on taking lecture notes and doing calculations. So when they can experience it, it seems to make a big difference in their level of understanding.
We argue all the time about which component of STEM is the most important, but actually all of them are integrated in such a way that if you pull one of those things out, you would not be able to describe that particular phenomena. STEM is a synthesis. You'll never go and find mathematics all by itself or technology all by itself. And so it's a very powerful instrument that allows students to pay attention to things they would normally not pay attention to, and it encourages a kind of understanding of how things come together.
The focus of today's lesson was collecting data and then beginning their data analysis, so determining their experimental probability for the data and beginning to consider which variables they might like to change. I think the advantage of an integrated math and science course is students don't shy away from the math quite as much. In this case, every single science inquiry that we do in this course has a matching math component.
The philosophical underpinnings of this course are rooted in sociocultural learning theory and brought to life by challenging students to solve real-world problems through constructive activity and modeling processes.
The wind turbine uses the fan's power to create electricity, and then when we flip the circuit, it'll power the pump. And I get to work with my hands and think about problems and work through them more than just sitting at a desk and writing down. It's more fun, and you get to learn in a better way.
Model-based reasoning and inquiry are at the core of what scientists, technologists, engineers, and mathematicians do, and therefore a natural means of integrating the STEM disciplines. Such a process emulates the actual practices of the STEM community.
Yeah, I think projects make learning more effective. I feel if you're hands-on with everything, you'll learn it better.
This class will integrate ideas from the teacher leadership and capstone courses to prepare candidates to become STEM teacher leaders.
There's a tremendous need for STEM educators. I think this course prepares all of its candidates so that they can be the STEM leaders that are going to shape what our STEM teaching workforce looks like over the next decades. So I think these STEM leaders in this program will learn how to support their peers as they develop their STEM teaching practices.
Participation in a collaborative learning community is essential for developing an innovative approach to STEM teaching. One of the ways in which candidates will gain support from their peers is by participating in the USC STEM Teacher Network, a professional learning community designed to help candidates develop leadership skills and form relationships that impact STEM teaching and learning locally, nationally, and globally throughout their science teaching career.
We hope that in that third course in particular, that they really get that sense of community, that professional planning, that professional advancement, moving forward and see themselves in the mirror and see themselves intellectually as STEM teachers.
I think the key to that is you need a network. We can't do this alone. You cannot transform STEM education by yourself. You need a whole network of peers to bounce ideas off of, to give you constructive criticism, and to support you when you're going to hit a wall in this very difficult endeavor. So I think the professional learning community that all candidates will participate in this class will be that network to give you support as you implement these practices that we're talking about, these STEM teaching practices, these integrated practices that will really change the way kids are going to learn science. And hopefully, with the goal is getting more kids interested in STEM careers.